April 5th, 1943. 14:37 hours. 28,000 feet above the North Sea. The air temperature hung at minus 40 degrees Celsius. Hauptmann Klaus Reinhardt sat in the cockpit of his Messerschmitt Bf 109 G6, leading a swarm of 4 fighters on an intercept mission against what German radar had identified as another American bombing raid heading toward Bremen. The leather of his gloves creaked as he gripped the control stick. The oxygen mask pressed cold against his face. Through the armored glass of his canopy, he could see forever, a crystal sky broken only by contrails and the distant specks that were his wingmen. Reinhardt was a veteran with 43 kills, a recipient of the Knight's Cross, a pilot who had flown since the Battle of Britain and survived when so many hadn't. He knew his aircraft intimately. Every vibration of the Daimler-Benz engine, every quirk of the controls, the precise moment when the 20mm cannon would jam if fired in sustained bursts above 7,000 meters. His 109 was fast, maneuverable, a thoroughbred fighter designed for one purpose: to kill bombers before they could devastate German cities. Then the radio crackled. Indianer at 2 o'clock high, climbing through our altitude. Reinhardt looked. What he saw made no tactical sense. American fighters, unmistakably American by their profile, were climbing toward his formation, climbing impossibly, maintaining altitude that should have been beyond their operational ceiling, coming from escort duties that should have forced them to turn back hundreds of kilometers ago. These were the new ones. The aircraft the intelligence briefings had mentioned, but dismissed. Republic P-47 Thunderbolts, the Americans called them. Massive fighters, weighing nearly 5 tons fully loaded, powered by engines so large they seemed grotesque. German pilots had nicknamed them Jugs, short for Juggernaut, and mocked them as bloated, as American excess made airborne, as confirmation that Americans didn't understand fighter design. They were supposed to be slow. They were supposed to lack maneuverability. They were supposed to run out of fuel halfway across the channel, certainly not to appear here, deep over German territory, climbing to altitude as if the thin air meant nothing. Reinhardt watched the first Thunderbolt roll into an attack dive, its massive radial engine thundering even through the sound-dampened cockpit. The American fighter accelerated in the dive with a speed that seemed to violate physics, seemed to mock everything Reinhardt knew about aircraft performance. He broke left, pulling his 109 into the defensive turn that had saved his life a dozen times before. But the Thunderbolt followed, in a dive, matching his turn. The massive American fighter moved like something possessed by physics Reinhardt didn't understand, diving through air so thin that German fighters lost power and maneuverability, yet somehow maintaining control, gaining speed, closing distance. The Thunderbolt's 8.50 caliber machine, guns open fire. Tracers carved through the space where Reinhardt's aircraft had been milliseconds before. He broke harder, feeling the 109 shudder at the edge of high-altitude stall, knowing the American behind him should be falling away, should be unable to sustain the turn, should be hemorrhaging speed and altitude. But the Thunderbolt stayed with him. And in that moment, watching his altitude indicator spin downward as he dove away from an enemy that shouldn't exist at this altitude, flying an aircraft that shouldn't perform this way, Reinhardt understood that something fundamental had changed. The Americans weren't playing by the rules anymore, if they ever had. For 2 years, German Fighter Command had operated with assumptions about American aircraft that seemed validated by every encounter. American fighters were adequate at best, inferior at worst. The P-40 Warhawk, which had equipped early American fighter groups, was slower than German fighters, less maneuverable, armed with guns that lacked the punch of German cannons. The P-38 Lightning, with its distinctive twin-boom design, had better range but was easy to identify and counter. The P-51 Mustang, in its early variants, was promising but handicapped by an unreliable Allison engine that robbed it of high-altitude performance. American bomber formations, the massive combat boxes of B-17 Flying Fortresses and B-24 Liberators, were formidable in their defensive firepower but vulnerable without escort. German tactics had evolved to exploit this vulnerability. Fighters would wait until American escorts reached their fuel limits and had to turn back, then tear into the bomber formations with cannon fire and rockets, achieving kill ratios that confirmed German tactical and technical superiority. The intelligence assessments compiled by Luftwaffe staff officers in late 1942 reflected confident certainty. A report dated November 1942 concluded, American fighter development lags behind German advancement by approximately 18 months. Their aircraft prioritize range and payload over performance. Their pilots, while brave, lack the training intensity and combat experience of Luftwaffe personnel. Current American fighter types pose minimal threat to experienced German pilots in modern aircraft. This assessment was based on rational analysis of observable data. The P-47 Thunderbolt, entering service in early 1943, seemed to confirm every German assumption about American design philosophy gone wrong. The aircraft weighed 17,500 pounds fully loaded, nearly twice the weight of a Bf-109G. Its Pratt & Whitney R-2800 double wasp engine displaced 2,804 cubic inches, a massive radial power plant that seemed to belong on a bomber rather than a fighter. German engineers, examining intelligence photographs and captured technical manuals, calculated that such an aircraft would be hopelessly outmatched against purpose-built German fighters. The weight-to-power ratio seemed adequate on paper, but suggested an aircraft that would be sluggish in turns, slow to accelerate, vulnerable in dogfights. The radial engine configuration would create excessive drag compared to the inline engines of German fighters. The massive airframe would present a large target, easy to hit, likely vulnerable to the lighter but more numerous weapons of German fighters optimized for bomber interception. Oberst Adolf Galland, one of Germany's most successful fighter aces and an influential voice in Luftwaffe fighter development, reviewed the P-47 specifications in January 1943 and reportedly commented, "The Americans have built a fighter that thinks it's a bomber. It will die like one." His assessment was shared throughout the fighter command structure. The Thunderbolt was seen as evidence that Americans, for all their industrial capacity, fundamentally misunderstood fighter design. The name itself, Thunderbolt, seemed to German ears like typical American bombast. They had their own nickname, Jug. It reflected their contempt. A jug was heavy, ungainly, useful only for carrying things, certainly not for fighting. Some German pilots called it the Amerikanisch Milchwagen, the American milk wagon, a slow, cumbersome vehicle that would be easy prey for sleek German fighters. But there were hints, even early on, that German understanding was incomplete. The first combat reports from units that encountered Thunderbolts in March and early April 1943 included details that didn't fit the expected pattern. P-47s were appearing farther from their bases than their fuel capacity should allow. They were engaging at altitudes where their massive radial engines should be gasping for oxygen. They were surviving damage that should have been catastrophic. A combat report filed by Lieutenant Werner Hoffmann on April 3, 1943, described an engagement that troubled his squadron commander. Intercepted P-47 formation at 7,800 meters. Achieved firing position and observed multiple strikes on leading aircraft. Expected target to catch fire or break up. Instead, American aircraft continued flying, maintained formation, and withdrew at high speed. Either our cannon shells malfunctioned, or this aircraft possesses structural strength beyond normal parameters. The structural strength was real, though German intelligence struggled to understand its implications. The P-47 was built around a philosophy of survivability that seemed wasteful to German engineers accustomed to calculating minimum necessary strength. The Thunderbolt's airframe could withstand combat damage that would tear apart a lighter fighter. Its radial engine, with 18 cylinders arranged in 2 rows, could lose multiple cylinders to battle damage and continue operating. The cockpit armor was so thick that German pilots reported their 7.92 mm machine gun rounds bouncing off. But weight and toughness alone didn't explain what German pilots were encountering in combat. The P-47 was proving fast, far faster than its bulk suggested. In dives, Thunderbolts were reaching speeds that exceeded anything German fighters could achieve. The massive aircraft was somehow achieving terminal velocities approaching 550 miles per hour, speeds at which German fighters began to experience control problems, but the P-47 remained stable and controllable. The first explanations German intelligence offered were reassuring. The Americans were sacrificing maneuverability for dive speed, were building an aircraft that could run away but couldn't fight, were compensating for pilot inadequacy with brute force engineering. These explanations satisfied command staff who needed to believe that German tactical and technical superiority remained intact. Then came the combat encounters that shattered these comfortable assumptions. April 1943 marked the operational debut of P-47s equipped with external drop tanks, auxiliary fuel tanks that could be jettisoned when empty, extending range without permanently adding weight. The technology wasn't new. German fighters used drop tanks, but the scale at which Americans applied the technology was unprecedented. German radar operators began reporting American fighter formations penetrating deeper into German airspace, reaching industrial targets that should have been beyond escort range, appearing over cities that German commanders had assumed were safe from American fighters. The bomber formations that had been easy prey once their escorts turned back were now arriving with fighter cover that stayed with them all the way to the target and all the way home. The mathematics didn't work. According to German calculations, a P-47 with internal fuel should have a combat radius of approximately 230 miles, enough to reach the French coast, engage briefly, and return. Yet American fighters were appearing over Bremen, over Hanover, over targets 300 miles from their British bases. The drop tank explanation helped, but even with external fuel, the numbers seemed impossible. German intelligence estimated that P-47s would need to fly at optimal cruise speeds, minimize combat maneuvering, conserve fuel religiously to achieve such range. Yet combat reports describe American pilots fighting aggressively, engaging in prolonged dogfights, and still having fuel to escort bombers home. What German analysts didn't fully grasp was that American industrial capacity extended to fuel production at scales that made conservation unnecessary. Each P-47 group was supplied with drop tanks in such quantities that every mission could carry maximum external fuel. Replacement tanks were manufactured by the thousands, treated as consumable items rather than precious equipment to be carefully managed. The Americans were fighting with an abundance mindset that seemed irrational to German officers accustomed to calculating every liter of aviation fuel. By late April 1943, combat reports were painting a picture that contradicted every assumption. Hauptmann Erich Hartmann, another high-scoring ace, submitted an after-action report that his superiors initially refused to believe. Engaged P-47 formation at 9,000 meters. American fighters matched our altitude, maintained energy in combat, and several achieved firing positions that should not have been possible given the aircraft's known performance characteristics. One P-47 pursued me in a dive, matching my speed despite my aircraft's lighter weight. I was forced to use emergency power to escape. This aircraft is not what we were told it was. The emergency power reference was significant. German fighters had systems that allowed brief boosts in engine performance beyond normal operational limits. Systems that damaged engines over time but could save a pilot's life in critical moments. That a German ace felt compelled to use emergency power to escape from an aircraft that was supposed to be inferior suggested something was fundamentally wrong with German intelligence assessments. The wrongness was profound. The P-47 wasn't just different from expectations. It represented a completely different design philosophy. Where German fighters were optimized for specific performance parameters, turn radius, climb rate, operational ceiling, the Thunderbolt was optimized for overall combat effectiveness. It was designed to excel not in any single measurement, but in the combination of characteristics that won actual fights: speed, firepower, durability, range. The massive 2800 engine that German analysts had mocked as excessive produced 2,000 horsepower in normal operation and could briefly generate over 2,300 horsepower with water injection boost. This raw power, combined with the aircraft's aerodynamic efficiency at high speeds, made the P-47 one of the fastest fighters in the sky once it built up velocity. In dives, it was untouchable. In level flight at high altitude, where the turbo-supercharged engine maintained power in thin air that choked German engines, it was formidable. The armament was equally overwhelming. 8.50 caliber Browning M2 machine guns, each loaded with approximately 425 rounds, gave the P-47 a total payload of 3,400 rounds. The combined rate of fire exceeded 100 rounds per second. When all 8 guns fired simultaneously, the aircraft shuddered from the recoil. The stream of bullets, a mix of armor-piercing, incendiary, and tracer rounds, could saw apart aircraft structures, ignite fuel tanks, kill engines, destroy control surfaces. German pilots who survived head-on passes against P-47s described the experience as flying into a wall of lead. The volume of fire was psychologically devastating even when it missed. When it connected, the results were catastrophic. Aircraft that survived multiple 20mm cannon strikes from German fighters were being shredded by sustained bursts from Thunderbolt guns. The tactical implications were becoming clear to frontline pilots, even as command staff clung to outdated assessments. The P-47 couldn't be fought using tactics developed against lighter, more maneuverable Allied fighters. It wouldn't bleed energy in vertical maneuvers the way British Spitfires did. It wouldn't stall out at high altitude the way early P-51s did. It wouldn't fall apart under heavy G-loads the way Soviet fighters did. A Luftwaffe tactical memorandum from May 1943 attempted to codify lessons learned. The P-47 must be engaged with caution. Avoid diving combat where the enemy holds advantage. Exploit superior turn radius at medium altitude. Do not pursue damaged P-47s. Their structural resilience often allows continued flight despite apparent mortal damage. Be aware that reported fuel limitations may be incorrect. American fighters are appearing at ranges previously considered impossible. The final sentence was the most ominous. If American fighters could reach targets previously safe from escort, then every German city, every factory, every strategic installation was potentially vulnerable. The carefully calculated defensive strategy, based on exhausting American escorts before they reached critical targets, was collapsing. May 17, 1943. The 8th Air Force launched a maximum effort against industrial targets in Regensburg and Schweinfurt. This was the deep penetration mission German commanders had expected and planned for. American bombers pushing far into Germany, beyond where escorts could follow, into range of the concentrated fighter forces waiting to tear them apart. Oberleutnant Franz Stigler, flying a Bf-109G6 out of Newburgh, climbed with his staffel toward the interception point. Intelligence had briefed them. The American bombers would arrive without escort. P-47s would turn back near the German border, their fuel exhausted. The bombers would be alone, vulnerable, perfect targets for German fighters that could attack with impunity. Stigler reached altitude and saw the American formation, a combat box of B-17s, their contrails riding white lines across the blue sky. He armed his weapons, checked his fuel, prepared for the attack run that would be repeated dozens of times that day, each pass chewing into the bomber formation, each burst of cannon fire adding to the toll. Then he saw them, P-47s, still with the bombers, an altitude and distance that shouldn't be possible. Not a handful, but dozens of them, weaving above the bomber formation in defensive positions, ready to pounce on any German fighter that approached. Stigler's squadron leader called the sighting to ground control. The response was confusion. The P-47s should have turned back. They should have exhausted their fuel. They couldn't be here, this deep over Germany, still in formation, still protecting the bombers. But they were. And when Stigler's squadron attempted to close on the bombers, the Thunderbolts dove to intercept. The engagement became a swirling dogfight at altitude, and Stigler experienced firsthand what other pilots had been reporting. The P-47 that engaged him didn't handle like a heavy aircraft. It rolled quickly for something so large. It followed him through maneuvers that should have bled its energy. And when Stigler attempted to dive away, a tactic that had always worked against Allied fighters, the Americans stayed with him, matching his dive speed, closing distance, forcing Stigler to pull out and evade before the 8 machine guns could find their range. Stigler survived the engagement. His wingman didn't. 17 German fighters were shot down that day. The American bombers, bloodied but still deadly, reached their targets with fighter escort that remained with them even into the heart of Germany. The impossible had become routine. The combat film from American gun cameras told a story that German intelligence could no longer dismiss. The footage showed P-47s engaging at altitudes German analysts had declared impossible. It showed sustained combat at ranges beyond calculated fuel capacity. It showed structural damage that should have been catastrophic. German cannon shells punching through wings and fuselage, followed by the aircraft continuing to fly, continuing to fight. One piece of footage, analyzed frame by Luftwaffe technical staff, showed a P-47 taking a direct hit from a 20mm cannon round in the engine cowling. The explosion was visible, metal fragments flying away from the impact point. German engineers expected to see the engine seize, to see fire, to see the aircraft begin its death spiral. Instead, the footage showed the P-47 continuing in formation, the massive radial engine apparently unaffected, the aircraft maintaining speed and altitude as if nothing had happened. The technical analysis concluded that multiple cylinders must have been destroyed by the hit, yet the engine continued operating on remaining cylinders. The redundancy was beyond anything German engines possessed. A similar hit on a Daimler-Benz inline engine would have meant immediate catastrophic failure. On the R-2800, it meant reduced power but continued operation. This survivability was changing the tactical calculus of air combat. German pilots were accustomed to aircraft falling from the sky when hit solidly. They expected enemy fighters to break off when damaged, to flee toward home, to become easy prey during the wounded retreat. P-47s violated these expectations. They absorbed damage and kept fighting. They protected each other. When one was damaged, others covered its withdrawal, making pursuit suicidal. The psychological impact on German pilots was cumulative and corrosive. Each engagement chipped away at confidence. The certainty that superior German technology and tactics would prevail was being replaced by doubt. If the aircraft intelligence dismissed as bloated and inferior was performing this well, what other American capabilities had been underestimated? Letters home from German pilots began to reflect this uncertainty. Feldwebel Hans Müller wrote to his wife in June 1943, "The Americans have a new fighter that seems to defy every rule we were taught. It is heavy but fast. It is large but agile. It is supposed to have limited range, but appears everywhere. We were told it would be easy prey. Instead, it hunts us." The range issue particularly troubled German tactical planners. Even accounting for drop tanks, the distances P-47s were operating at suggested fuel management far beyond German capabilities. What the Germans didn't fully understand was that American logistical support had transformed external fuel tanks from occasional range extenders to standard equipment manufactured in vast quantities. Republic Aviation and its subcontractors were producing drop tanks by the tens of thousands. They were stamped from sheet metal using mass production techniques, treated as consumable items that cost less than a single 20mm cannon shell. American P-47 units could equip every aircraft with maximum external fuel for every mission without concern for tank availability. This abundance allowed operational flexibility German fighters couldn't match. The Americans were also developing new tank designs with larger capacity. The initial 75-gallon tanks were being supplemented by 108-gallon tanks, then 150-gallon tanks. Each increase extended combat radius, pushed the escort coverage deeper into Germany, made more targets vulnerable to American bombers protected by fighters that seemed to have unlimited endurance. German industry, by contrast, struggled to produce enough fighters to replace combat losses, let alone manufacture auxiliary equipment in the quantities Americans treated as routine. Drop tanks for German fighters existed, but were rationed, distributed carefully, used sparingly. The idea of discarding a tank without attempting recovery would have seemed wasteful to German logistics officers. Americans discarded thousands of them, littering the European countryside with aluminum evidence of industrial abundance. By summer 1943, the operational reality was undeniable. The P-47 Thunderbolt, dismissed as suicide plane by German intelligence when it first appeared, had become the most feared fighter in the European theater. It escorted bombers to targets throughout Germany. It engaged German fighters on equal or better terms. It survived damage that killed other aircraft, and it was being produced in numbers that made individual losses tactically meaningless. The production statistics revealed the full scope of American industrial mobilization. Republic Aviation's factory in Farmingdale, New York, was producing P-47s at a rate exceeding 100 per month by mid-1943. Curtiss-Wright's Buffalo plant added additional production capacity. By the end of 1943, over 3,000 P-47s had been delivered to combat units. By war's end, total production would exceed 15,600 aircraft, making the Thunderbolt one of the most produced American fighters despite its size and complexity. German fighter production, while impressive in absolute terms, couldn't match this output. The Bf-109, Germany's primary fighter, reached peak production of approximately 14,000 units in 1944, a respectable figure until compared to American numbers. And Germany was producing for a single front essentially, while America was supplying aircraft to the Pacific, to Britain, to the Soviet Union through Lend-Lease, while still maintaining overwhelming numerical superiority in Europe. The mathematics of attrition warfare were turning decisively against Germany. Even if German pilots achieved favorable kill ratios, and increasingly they weren't, American losses were being replaced faster than they were inflicted. Every P-47 shot down was replaced by 2 more. Every pilot killed was replaced by 3 more, completing training in a vast American flight training apparatus that treated pilot production as an industrial process. Hauptmann Walter Nauetny, one of Germany's highest-scoring aces, captured the existential dread this realization created. We can shoot down Americans all day, every day. We can achieve victories our grandfathers would celebrate as legendary. And tomorrow there will be more Americans, in newer aircraft with better tactics, supported by resources that seem unlimited. How do we win a war against an enemy that treats our greatest victories as acceptable losses? The question had no answer that German command could provide. The strategic situation was deteriorating on every front. The Soviet Union was mobilizing its own vast industrial base, grinding down German forces in the east through sheer weight of numbers. American industrial capacity was flooding the European theater with weapon systems that negated German tactical advantages. And overhead, the P-47 Thunderbolts flew in formations so large they seemed to darken the sky. A daily reminder that the war of industrial production was being won by the side with factories that operated on scales Germany couldn't match. The industrial revelation German pilots were experiencing in the sky over Europe was being simultaneously experienced by German civilians in the cities below. The strategic bombing campaign that the P-47s made possible was transforming German industrial capacity from engine of war into victim of war. The sequence was straightforward and devastating. P-47s escorted bombers to targets. The bombers destroyed factories, rail yards, oil refineries. The destruction reduced German industrial output. Reduced output meant fewer replacement aircraft, less ammunition, decreased fuel availability. This degradation made it harder for German fighters to oppose subsequent raids, which meant more bombers got through, which meant more destruction. a death spiral of industrial collapse driven by the simple fact that American production exceeded German production by margins that made strategic victory impossible. By late 1943, German civilians were experiencing shortages that reflected this industrial imbalance. Food rations decreased as agricultural production was disrupted by bombing and labor shortages. Consumer goods disappeared from shops as factories converted to military production or were destroyed. The promised weapons that would turn the tide, jet fighters, advanced submarines, rockets, remained in development while Allied forces grew stronger through the brute force application of mass-produced conventional weapons. The psychological impact was profound. Germans had been told they were the master race, that their technical and organizational superiority would ensure victory, that Allied industrial capacity was propaganda exaggeration. The reality, visible in the American bomber formations that flew overhead with increasing impunity, audible in the thunder of P-47 engines escorting them, tangible in the rubble of bombed cities, contradicted everything they had been promised. Albert Speer, Minister of Armaments and War Production, recognized the implications early. In a meeting with Hitler in May 1943, shortly after the first long-range P-47 missions, Speer presented calculations showing that American aircraft production alone exceeded total German production of all weapons types. His conclusion was stark. The Americans are outbuilding us by factors we cannot overcome. They can afford to lose aircraft at rates that would devastate our fighter forces and still maintain numerical superiority. This is not a war we can win through industrial production. Hitler rejected the analysis, insisting that German fighting spirit and technological innovation would prevail. But Speer's numbers were irrefutable. In 1943, the United States produced 85,898 aircraft. Germany produced 24,807. The ratio was more than 3-to-1. And this didn't account for the qualitative improvements in American aircraft or the logistical support that made American numerical superiority even more decisive. The fuel situation illustrated the disparity with particular clarity. The United States produced approximately 1.5 billion barrels of oil in 1943. Germany, even after seizing Romanian oil fields and developing synthetic fuel production, produced approximately 35 million barrels. American fighters could operate without careful fuel conservation because replacement fuel was effectively unlimited. German fighters rationed every liter, abbreviated training flights to conserve aviation gasoline, grounded units when fuel shipments were delayed by Allied bombing. This fuel poverty created a vicious cycle. German pilots received less flight training because fuel for training was scarce. Less training meant higher combat losses. Higher combat losses meant more replacement pilots needed training. But training capacity was limited by fuel availability. The result was declining pilot quality over time, even as American pilot training programs, supported by seemingly unlimited aviation gasoline, produced progressively better trained replacements. A German flight instructor, Hauptmann Otto Schulz, documented this decline in a report from September 1943. New pilots arrive at operational units with 60 hours of flight time. American pilots reportedly receive 400 hours before combat deployment. We are sending children against veterans, not because our training philosophy is flawed, but because we lack the fuel to train them properly. They die on their first or second mission. We cannot sustain this attrition. The 400-hour figure Schultz cited was accurate. American pilot training had been standardized and industrialized, with training bases across the United States producing pilots using consistent curricula. The flight training program treated pilots as products moving through an assembly line. Primary training, basic training, advanced training, operational training, each stage adding skills and experience before the pilot faced combat. The fuel to support this training came from American oil fields that produced more in a day than some German synthetic fuel plants produced in a month. The aircraft used for training, often older models retired from frontline service, numbered in the thousands, replaced when worn out, maintained by a logistics system that treated spare parts as infinite resources. German training, by contrast, was conducted with aircraft and fuel that were desperately needed at the front. Every hour a Bf 109 spent training a new pilot was an hour it wasn't engaging Allied bombers. Every liter of fuel burned in training was a liter unavailable for combat operations. The trade-offs were agonizing and ultimately unsustainable. The disparity extended to pilot replacement rates. American fighter groups losing pilots in combat receive replacements within days. New pilots fresh from training, eager but competent, ready to be integrated into operational units. German fighter groups losing pilots often waited weeks for replacements, if they came at all. Units were kept in combat even as they fell below effective strength, their remaining pilots flying multiple missions per day, exhaustion degrading performance, losses mounting. Oberleutnant Heinz Noack, a veteran fighter pilot, described the grinding attrition in his diary. "We are being worn down not by superior skill, but by endless numbers. Every day, more Americans. Every day, our numbers smaller. We fight well, achieve victories, and it matters not at all because tomorrow there will be more of them and fewer of us. This is not war. This is mathematics." The mathematics were indeed decisive. By the end of 1943, German fighter losses exceeded production by significant margins during some months. The deficit was covered by cannibalizing damaged aircraft, extending the service life of worn-out planes, and accepting declining readiness rates. American fighter units, meanwhile, were receiving aircraft faster than they could be distributed, with new P-47s sometimes waiting at depots because frontline units couldn't absorb them quickly enough. The quality of those aircraft was improving continuously. Later variants of the P-47, the D model that entered service in 1943, incorporated combat lessons with remarkable speed. The bubble canopy improved visibility. Strengthened wing structures allowed heavier ordnance loads. Engine improvements increased power output. Each refinement made the aircraft more effective, and the refinements were being implemented across thousands of airframes through American industry's ability to modify production lines rapidly. German aircraft improvement, by contrast, was limited by production constraints. New variants of the Bf 109 and FW 190 incorporated innovations, but implementing changes across the entire production run was complicated by dispersed manufacturing and resource limitations. Improvements that American factories could implement in weeks took months in Germany, if they were implemented at all. The maintenance disparity compounded these advantages. American fighter units had mobile repair facilities that could rebuild damaged aircraft in the field. Spare parts were available in quantities that allowed replacement of worn components before failure. German units often flew aircraft with degraded engines, worn weapons, patched battle damage because replacement parts were scarce and repair facilities overworked. A German maintenance officer, Hauptmann Friedrich Weber, submitted a report in December 1943 that illustrated the frustration. Request for replacement propellers denied. None available. Request for engine overhaul kits denied. Allocated to other units. Request for gun barrels denied. Production delayed. We are operating aircraft at 60% readiness, not because of combat damage, but because we cannot obtain parts to maintain them. Meanwhile, we observe American aircraft landing with minor damage and returning to service within hours. They have everything. We have nothing. The everything Weber referenced extended beyond spare parts to include infrastructure Americans built with stunning speed. Airfields in England were being constructed and expanded using American engineering battalions equipped with earth-moving equipment on scales that seemed fantastical to German observers. Runways, hangars, fuel storage, ammunition bunkers, entire air bases appearing in months where German construction would require years. The logistics to support these bases was equally impressive. Supply ships crossed the Atlantic carrying aviation fuel, bombs, ammunition, spare parts, food, medicine, everything needed to sustain air operations. German U-boats sank some ships, but American shipbuilding replaced losses faster than they were inflicted. The convoy system that kept Britain supplied and American air bases operational was itself an industrial marvel that Germany had no counter for. By early 1944, the strategic situation had become hopeless for German air defense. The P-47s that had been called suicide planes were now operating with such dominance that German fighters often avoided combat, preserving strength for critical defense of key targets rather than engaging every American formation. The sky over Germany, once defended with confidence, was becoming American domain. The final humiliation came in the form of ground attack. P-47s, having established air superiority, began attacking ground targets with devastating effectiveness. The 8 machine guns that had proven deadly against German aircraft were turned against trains, trucks, tanks, troop columns. The aircraft that was supposed to be a bloated failure was destroying German logistics, interdicting supply lines, turning roads into killing zones. German soldiers learned to fear the sound of R-2800 engines. That distinctive thunder meant P-47s were hunting, meant that movement in daylight invited destruction, meant that the Americans controlled not just the air, but everything beneath it. The fighter that couldn't possibly work had become the symbol of Allied air dominance, a daily reminder that American industrial capacity had overwhelmed German technical excellence through the simple expedient of producing better weapons in greater numbers. Lieutenant Colonel Francis Gabreski sat in the cockpit of his P-47D at Duxford Airfield, England, on June 5, 1944, D-Day-1. He was the leading American ace in Europe at that point, with 28 confirmed kills, most of them achieved while flying the Thunderbolt. Tomorrow, he would fly cover for the greatest amphibious invasion in history, part of a fighter force so massive that German opposition would be swept aside like leaves before a hurricane. Gabreski thought about his first reaction to the P-47 when he transitioned to it from P-40s. The aircraft had seemed impossible, too big, too heavy, too much. His fellow pilots had joked about needing a stepladder to climb into the cockpit. The aircraft had been nicknamed the Jug, and not affectionately. Everyone knew the nimble German fighters would eat it alive. Then they'd flown combat, and everything changed. Gabreski remembered his first kill in a P-47 back in August 1943. He'd been escorting bombers near Gelsenkirchen when FW-190s attacked. He'd engaged one, expecting the dogfight to favor the more maneuverable German fighter. Instead, the Thunderbolt had responded to his inputs with surprising agility. When the German tried to dive away, a tactic that usually worked, Gabreski had followed, the big Pratt & Whitney engine pushing the P-47 to speeds the FW-190 couldn't match. The 8.50 calibers had done the rest. After that mission, his squadron mates had stopped joking about the Jug. They'd started calling it the Undefeated instead, a reference to the fact that no P-47 had yet been shot down in a one-on-one dogfight by a German fighter. The aircraft they dismissed as a death trap was proving nearly invulnerable. Now, on the eve of invasion, Gabreski commanded a squadron of P-47s that would provide fighter cover so dense that German aircraft would barely penetrate it. He knew the numbers. The Allies would have over 11,000 aircraft supporting the invasion. The Luftwaffe could muster perhaps 300 operational fighters in the region. The arithmetic was crushing, but it was more than numbers. It was capability. Each P-47 carried enough fuel to loiter over the beaches for hours. Each carried enough ammunition to engage multiple targets. Each was tough enough to absorb ground fire and keep flying. The aircraft that was supposed to be a failure had become the perfect tool for the mission. Overwhelming firepower, endless endurance, and the survivability to operate in the most hostile environments. Gabreski closed the canopy and ran through his pre-flight checks. The big radial engine caught and settled into its characteristic rumble. Tomorrow, this sound, multiplied by hundreds, would be the anthem of liberation for occupied France. The Germans would hear it and know their defeat was inevitable, because the aircraft they'd mocked as a suicide plane had become the instrument of their destruction. Across the channel, Hauptmann Joseph Pips Priller sat in the operations room at Luftwaffe headquarters near Paris, staring at reports that made no strategic sense. His fighter wing, Jägerschwader 26, one of the Luftwaffe's most decorated units, had been reduced to a shadow force. Of the 124 aircraft on paper, only 8 were operational. The rest were grounded for lack of fuel, lack of parts, or lack of pilots to fly them. The invasion everyone knew was coming would arrive with Allied air superiority so complete that Priller's fighters would be little more than nuisances. He had requested reinforcements, fuel, ammunition, anything to make his unit combat effective. The responses were all variations of the same theme. Resources were unavailable, prioritized elsewhere, consumed by the grinding attrition on the Eastern Front and the defense of the Reich. Priller had flown against the Americans since 1943. He had watched the evolution of their tactics, the improvement of their aircraft, the relentless increase in their numbers. He had shot down P-47s, 3 of them, victories he was proud of because they were so difficult to achieve. But for every Thunderbolt he destroyed, 10 more appeared. The Americans fought with the confidence of men who knew losses were temporary, replacements inevitable, victory certain. He thought about the intelligence briefings that had called the P-47 a suicide plane, an aircraft so flawed it would barely impact the war. Those assessments seemed like artifact from another reality, documents from a world where German technical superiority was fact rather than fading memory. The Thunderbolt hadn't just succeeded. It had redefined what success meant in fighter aviation. When the invasion came on June 6, 1944, Priller would lead a desperate 2-aircraft mission, the only fighters his unit could put in the air, in a symbolic gesture of resistance against an invasion force supported by thousands of Allied aircraft. He would strafe the beaches at Sword, emptying his guns into the mass of humanity below, achieving nothing of strategic value, surviving only because the Allied fighters were too busy with more important targets to bother with 2 lone German fighters. That mission would become legend in Luftwaffe history, the courage of 2 pilots against impossible odds. But Priller would know the truth. It was the epitaph of German air power, the final proof that courage without industrial support was merely theater. The sky belonged to the Americans now, and their P-47s patrolled it with the casual dominance of an unchallengeable power. The strategic bombing campaign reached its crescendo in 1944, and the P-47 played a central role in its success. The long-range escorts that had seemed impossible in 1943 became routine. American bombers struck Berlin, Munich, Stuttgart, targets deep in Germany that had once been safe from daylight raids. The Thunderbolts escorted them there and back, fighting through German defenses that grew progressively weaker as attrition ground down the Luftwaffe. The kill ratios told the story. In early 1943, German fighters had achieved favorable exchange rates against American bombers and their escorts. By late 1944, the ratios had reversed catastrophically. For every American aircraft lost, German fighters were being destroyed at rates of 3 to 1, 4 to 1, sometimes higher. The mathematics of aerial combat had shifted from German advantage to German catastrophe. German ace Werner Mulders had famously said, "The fighter pilot's job is to shoot down enemy aircraft." By 1944, that job had become nearly impossible for German pilots. They were outnumbered, outperformed, flying aircraft with degraded engines and worn weapons against enemies operating at peak efficiency. The Americans had more aircraft, better training, unlimited fuel and ammunition, and tactics refined through continuous combat experience. The P-47 groups developed techniques that exploited their aircraft's strengths ruthlessly. They would engage German fighters at high altitude, where the turbo-supercharged engines gave them power advantages. They would use speed to dictate engagement terms, diving to attack, climbing away to reset, refusing to fight in the slow-speed turning battles where German fighters held advantages. And when they caught German fighters in disadvantageous positions, the 8.50 calibers delivered devastating firepower. The psychological toll on German pilots was severe and cumulative. Major Heinz Bahr, who survived the war with 220 victories, later described the feeling of facing American formations in 1944. You would see them coming, formations of 50, 60 bombers, each one surrounded by fighters. P-47s above, P-51s on the flanks, P-38s below. They had aircraft for every altitude, every mission, every tactical situation. We would attack knowing we might damage a few bombers, might shoot down one or two fighters, and would almost certainly lose several of our own. It was mathematics that always favored them. The spring offensive of 1944, designed to cripple the Luftwaffe before D-Day, achieved its objectives through the systematic application of overwhelming force. American fighters didn't just escort bombers. They actively hunted German fighters, seeking combat, destroying aircraft on the ground, attacking airfields and rail lines. The P-47, with its ability to carry bombs and rockets in addition to its guns, became a devastating ground attack platform. German airfields became death traps. P-47s would appear at dawn, strafing aircraft lined up for takeoff, destroying fuel trucks, demolishing hangars. The attacks came daily, relentlessly, forcing German units to disperse aircraft, which degraded operational efficiency and made coordination difficult. Pilots arriving at airfields for briefings would hear the engines overhead and run for cover, watching helplessly as their fighters were destroyed on the ground. The fuel situation became critical. Synthetic fuel plants, targeted by American bombers escorted by P-47s, were destroyed faster than they could be repaired. Aviation gasoline stocks dwindled. By June 1944, some German fighter units were grounded not by combat losses, but by empty fuel tanks. The aircraft existed, the pilots were trained, but without fuel they were useless, expensive metal sculptures marking the grave of German air power. The contrast with American logistics was stark and demoralizing. American fighters operated from bases in England where fuel arrived by tanker, where ammunition was stacked in warehouses, where every consumable item was available in quantities that seemed to mock the concept of scarcity. German interceptors scrambled knowing they had fuel for perhaps one mission, that landing gear failures couldn't be repaired for lack of parts, that pilots shot down couldn't be replaced. Major Walter Nauetny, one of the Luftwaffe's most successful aces with 258 victories, was killed in November 1944 while flying the new Me-262 jet fighter, the technological marvel that was supposed to restore German air superiority. He was shot down by P-47s. The symbolism was devastating. The newest, most advanced German fighter, piloted by one of Germany's best, destroyed by the aircraft that had been dismissed as obsolete before it even entered service. The Me-262 itself illustrated the paradox of German technical innovation versus American industrial capacity. The jet was faster than any Allied fighter, armed with powerful cannons, genuinely revolutionary. But Germany could produce them only in limited numbers, fuel for them was scarce, and training pilots to fly them was nearly impossible given the shortage of aviation gasoline for jet training. The few that became operational were hunted by swarms of P-47s and P-51s that caught them during takeoff and landing, when their speed advantage meant nothing. American intelligence officers interviewing captured German pilots in late 1944 heard the same themes repeatedly: exhaustion, hopelessness, the recognition that courage couldn't overcome material disadvantage. One pilot, whose name was redacted in the interrogation report, summarized the German perspective with brutal clarity. "You asked why we keep fighting when we know we've lost. Because we are soldiers and we have orders. But every pilot knows the truth. The Americans have won the air war. They won it with the aircraft we were told would fail, the P-47, the P-51, even the P-38. They won it not through superior courage or tactics, but through building more aircraft than we could shoot down, training more pilots than we could kill, producing more fuel and ammunition than we could exhaust. They won it in their factories, and we lost it in ours." The aftermath of the European air war shaped aviation doctrine for generations. The lessons learned were codified, analyzed, incorporated into post-war aircraft development and military planning. The P-47's success validated design philosophies that prioritized overall combat effectiveness over optimization for specific performance metrics. American aircraft designers absorbed the lesson that survivability mattered, that bringing pilots home alive meant they could fight again, accumulating experience that made them progressively more effective. The P-47's ability to absorb punishment and continue flying had saved countless pilots who would have died in more fragile aircraft. Those pilots survived to pass on their knowledge, to train new pilots, to contribute to the progressive improvement of tactics and techniques. The industrial lesson was equally profound. The Thunderbolt had succeeded because American industry could produce it in numbers that made losses acceptable. But more importantly, American industry had shown the ability to improve the design continuously, incorporating combat feedback into updated variants, solving problems through engineering iteration rather than acceptance of limitations. By war's end, over 15,600 P-47s had been produced across multiple variants. The final versions, the P-47M and P-47N, were dramatically improved over early models, with more powerful engines, better aerodynamics, increased range. The N model, designed for Pacific operations, had a combat radius exceeding 1,000 miles, allowing it to escort B-29s to Japan and back. The aircraft that had been mocked as having inadequate range in 1943 had evolved into one of the longest-ranged fighters of the war. German aviation, by contrast, ended the war with revolutionary designs that never achieved their potential. The Me-262 jet, the He-162 Volksjäger, the rocket-powered Me-163, all represented technical achievements that couldn't be produced in numbers or supported logistically. The Germans had proven they could innovate, could design remarkable aircraft, but couldn't sustain production or provide the fuel and pilots to make innovation matter strategically. The post-war Luftwaffe, reconstituted under NATO, absorbed American doctrine wholesale. German pilots trained in American aircraft, learned American tactics, adopted the industrial warfare approach that had defeated them. The cultural transformation was complete. The Luftwaffe that had emphasized individual prowess and aircraft performance became a force emphasizing systematic training, logistical support, and the integration of air power into combined arms operations. The P-47 itself remained in service with various air forces into the 1950s. It flew combat missions in the Korean War, proving that the design's fundamental strengths, durability, firepower, reliability, retained value even as jet aircraft began dominating the sky. Air National Guard units flew P-47s until 1953, a testament to the aircraft's longevity and continued effectiveness. But the Thunderbolt's greatest legacy was psychological and philosophical. It had proven that democratic industrial systems, when mobilized for war, possessed advantages that authoritarian systems could match. The free market capitalism that produced the P-47, with its emphasis on efficiency, innovation, and response to user feedback, had demonstrated superiority over centrally planned economies in the specific domain of war production. This lesson informed Cold War strategy. American military planners consistently bet that Soviet industrial capacity, while substantial, couldn't match American productivity in quality or quantity over sustained periods. The strategy of containment assumed that economic competition would favor democratic capitalism, that the Soviets would exhaust themselves trying to match American military production while maintaining living standards for their population. That assumption proved correct when the Soviet Union collapsed in 1991, defeated not by military conquest, but by economic exhaustion, unable to sustain the industrial competition with an American economy that produced both military strength and consumer prosperity. The P-47's lesson, that abundance defeats scarcity, that industrial capacity is strategic power, had been validated again on a global scale. In 2007, a reunion of P-47 pilots was held at the Air Force Museum in Dayton, Ohio. The men who attended were in their 80s, veterans of a war 60 years past, gathering to remember aircraft and battles that had shaped their lives and the world. They walked past the restored P-47D on display, its polished aluminum skin reflecting museum lights, its massive propeller frozen in mid-rotation. Francis Gabreski was there, age 88, still carrying himself with the bearing of the fighter pilot he'd been. He stood before the aircraft and spoke to the younger generation of pilots and historians gathered for the event. They told us this aircraft was too heavy to fight, too big to maneuver, too complex to maintain in combat conditions. Everything about it violated the conventional wisdom of fighter design. We flew it anyway, because it was what we had, and we discovered it was exactly what we needed. It brought us home when lighter fighters would have fallen from the sky. It carried us to targets our enemies thought were safe. It delivered firepower that made enemy fighters afraid to engage. It was abundant when everything else was scarce. The Germans had better training, more experience, sometimes better tactics. But we had P-47s, and America could build them faster than anyone could destroy them. That was the real weapon, not the aircraft itself, but what it represented. American industry, fully mobilized, producing tools of war on scales that made victory inevitable. The Germans were fighting with scarcity, calculating every resource, trying to achieve maximum effect with minimum means. We were fighting with abundance, with the knowledge that behind every aircraft lost stood a factory producing replacements. The P-47 taught us that modern war is won in factories before it's fought in battles. The side that can produce more, sustain more, replace more, that side wins given time. The Germans called it a suicide plane because they couldn't imagine an aircraft that big and heavy succeeding. We called it the Thunderbolt, and we rode it to victory. An elderly German man stood near the back of the crowd, a former Luftwaffe pilot who had emigrated to America after the war, who had found peace and prosperity in a nation that had defeated his homeland. He approached Gabreski after the speech, introduced himself, mentioned they had probably tried to kill each other over Germany in 1944. The two old pilots stood together before the P-47, and the Germans spoke quietly. I shot at this aircraft many times. I saw my bullets hit it, saw pieces fly off, expected it to fall. It never did. It just kept coming, kept fighting. I thought it was luck. Later I understood it was engineering. You built aircraft that could survive our weapons. We built aircraft that couldn't survive yours. The war was decided by that difference, multiplied across thousands of aircraft, millions of rounds of ammunition, endless industrial capacity. I hated this aircraft once. It killed friends of mine. It represented everything we were told was wrong with American military thinking. Wasteful, excessive, inelegant. But it worked. And our elegant, efficient, perfectly calculated aircraft lost to your excessive, wasteful, inelegant one. Perhaps there's a lesson in that about the difference between our systems. Yours produced abundance through freedom. Ours produced scarcity through control. Your abundance won. Gabreski nodded, looking at the aircraft that had carried him through war. It wasn't just the plane. It was everything behind it. Every factory worker who built them. Every engineer who improved them. Every logistics officer who got them to bases in England. Every mechanic who kept them flying. The whole nation mobilized, producing not just aircraft, but the complete system needed to employ them effectively. The P-47 was the symbol of that system. It was big because we could afford big. It was heavy because we could afford the fuel to fly it. It was complex because we had the industrial base to maintain it. Everything the Germans saw as weakness was actually strength. The strength to build what worked rather than what fit preconceived notions of efficiency. The two old enemies, reconciled by time and shared humanity, stood together in silence before the machine that had helped decide their fates and the fate of the world. The museum visitors walked past, many unaware of the significance of the aircraft or the men standing beside it. But history knew. History remembered. The P-47 Thunderbolt, called a suicide plane by enemies who couldn't imagine it would work, feared as the most deadly machine in the sky by those who encountered it in combat, stood as permanent testimony to a simple truth. Industrial democracies, when aroused to action, possess advantages that no amount of tactical skill or technical elegance can overcome. The factories that built the Thunderbolt, the logistics that sustained it, the training that produced pilots to fly it, the fuel that powered it, the ammunition that armed it, all represented the mobilization of free people toward common purpose. That mobilization more than any single weapon or tactic, won the air war over Europe. And the lesson echoed forward through time, a warning inscribed in aluminum and steel. Never underestimate the productive capacity of a free nation mobilized for righteous purpose. For they will build not just weapons, but systems. Not just aircraft, but fleets. Not just bullets, but storms of fire. And they will sustain that production until victory is not hoped for, but inevitable. Not possible, but certain. Not a dream, but mathematics. The German admirals mocked American carriers at Midway, until the factories buried their fleet. The Luftwaffe called the P-47 a suicide plane, until it owned the sky. The pattern was clear, the lesson eternal. Industrial abundance, born of freedom and sustained by democracy, defeats scarcity every time. The thunder of the Thunderbolt was not just the sound of its engine. It was the thunder of American factories working around the clock, of assembly lines producing aircraft by the thousands, of a nation transforming its productive capacity from commerce to combat and overwhelming its enemies not through superior courage, but through superior production. They called it the suicide plane. It became their nightmare, and the sky remembers.